the carrier. We already discussed the definition of the DSBSC. Here carrier is completely independent of modulating signal m of t. So m of t is called as the modulating signal, which means that the transmission of the carrier wave represents a wastage of power. So we already discussed that. That means the power of the carrier wave is wasted. தேவையில்லாமல் சும்மா அதை ஆம்ப்ளிடியூட் ஆகி வெளியில் வர்ற அந்த வேவ்ஸில் கேரியர் வேவ்ஸ் அப்படியே நம்ம இன்புட் என்ன கொடுக்குறோமோ அதே அப்படியே வெளியில் வர்றது தான் அவுட்புட் வேவ்ஸ்ன்னு சொல்லுவோம். கிளாஸ் இந்த ப்ரீவியஸ் கிளாஸ் ஒரு 2 to 3 classes பேக் we already discussed. 2 class 3 கிளாஸ்க்கு முன்னாடி டிஸ்கஸ் பண்ணியிருக்கணும். So what we have discussed that, can listen. So in this diagram, so 2 or 3 classes before we have discussed this amplitude modulated wave. So in this case unmodulated carrier waves. So power of this unmodulated carrier wave is not necessary. இது எல்லாமே unmodulated carrier wave தான். அப்போ இந்த மாடுலேட்டட் வேவ்ஸஸ், இந்த ஆம்ப்ளிடியூட் மாடுலேஷன் நடந்து போயிட்டு இருக்கும்போது இந்த வேவ்ஸோட பவர் வேல்யூ வேஸ்ட் இல்லைங்களா. அப்போ இது நமக்கு தேவையில்லை. ஸோ அன்மாடுலேட்டடு கேரியர் வேவ்ஸோட பவர் நமக்கு தேவையில்லை. அப்போ இதை ரிமூவ் பண்ணி, ஸோ தட் மீன்ஸ் வேஸ்டேஜஸ் ஆஃப் தி பவர் ஆஃப் தி அன்மாடுலேட்டட் வேவ் அதுதான் இங்கே சொல்லுது. ஸோ தட் மீன்ஸ் ஸோ த வேஸ்ட் ஆஃப் தி பவர் ஆஃப் அன்மாடுலேட்டட் வேவ்ஸ். நெக்ஸ்ட் கேஸ், efficiency of transmission can be improved by suppressing the carrier from modulated wave. அப்போ அந்த கேரியர் வேவ்ஸோட பவர், ஸோ அந்த கேரியர் வேவ்ஸோட பவர் இருக்குன்னு சொன்னீங்களா, அன்மாடுலேட்டட் கேரியர் வேவ்ஸோட பவர், ஸோ இட் ஹாஸ் பீன் சப்ரஸ்ட், அதாவது சப்ரஸ்டு ஃப்ரம் த மாடுலேட்டட் வேவ். திஸ் ரிசல்ட்ஸ் இஸ் நோன் அஸ் double sideband suppressed carrier modulation, that means DSBSC. So this DSBSC or a double sideband suppressed carrier modulation is obtained by taking the product of carrier C of t and modulating signal, that means message signal m of t as follows. That means product modulator has been generated in this double sideband suppressed carrier. That means product of carrier wave order product, the carrier wave mathematical equation C of t and the signal, input signal or message signal or modulating signal m of t as follows. That means modulating signal x, modulating signal not x, modulating signal means m of t. Okay, modulating signal m of t and the carrier signal C of t, it has been multiplied. So that is product modulator takes place. That resultant modulated wave is called double sideband suppressed carrier signal. So it has to be transmitted through the antenna into the channel. Okay, so this is called as the double sideband suppressed carrier introduction. Next, we know the mathematical definition for message signal and mathematical formula for carrier signal. So what is the mathematical formula for the message signal and the carrier signal? Let me imagine. So these are the definitions. So at the product modulator, S of t equal to, S of t means double sideband suppressed carrier, double sideband suppressed carrier modulated waves. S of t equal to product modulator, the product of m of t and C of t. That is equation number 1. Let me imagine. Okay, so here S of t means amplitude modulation of double sideband suppressed carrier and C of t equal to, so we know the formula for C of t, AC into cos omega c t, cos omega c t. Here cos means that both modulating signal and the carrier signals, both of them are sinusoidal waves. So due to the sinusoidal waves, we have to using this cos function for this carrier waves. That is equation number 2. So substitute equation 2 in equation 1. Therefore equation 1 becomes, how it will become? So equation 1 becomes S of t equal to, S of t equal to AC m of t into cos omega c t. Okay, so that is an equation. Here, this is equation number 3. Let us imagine signal. Low frequency baseband signal like a message signal. Okay, so the message signal message signal. Then, so double sideband suppressed carrier. In the double sideband suppressed carrier, we can get case unnecessary carrier waves have been neglected, so suppressed at the same time. So the upper sideband and the lower sideband, both of them has been considered. Upper sideband and lower sideband, both of them has been considered for in this case, as well as the phi value is equal to 0. The phi is equal to 0. Here the phi is also be equal to 0. So that means a phase reversal. So that's what the phase value will be equal to 0. Okay. So this is the explanation for the double sideband suppressed carrier. Next one is mathematical expression. Mathematical expression for double sideband suppression for double sideband suppressed carrier. This DSBSC, it can be explained by mathematically because we are using the product modulator. So we know the formula. So that means double sideband suppressed carrier amplitude modulation S of t equal to multiplication or product of a message signal and a carrier signal. So that is equal to AC m of t into cos omega ct. Here omega means angular frequency. So what is the value of angular frequency? 2 pi f. So omega c equal to 2 pi fc. That is equation number 3. So AC m of t into cos 2 pi fc into t, that is equation number 3. Now we are going to take a Fourier series on both sides on equation number 3. Okay, so then in equation 3 we are going to take a Fourier transforms. So that we are applying the Fourier transforms on both sides of equation 3. So Fourier transform of double sideband suppressed carrier S of t is equal to Fourier series of the right hand side. So that means when you are introducing the Fourier transform in that expression, so we can get this value. So Fourier transforms. Fourier transform of DSBSC is equal to AC is a common, it has been taken out. Okay, so the AC is a common value is taken out. Here AC is a constant, it is taken out. So that's what AC into Fourier transform of m of t into, so that means the remaining values cos 2 pi fct. So the cos 2 pi fct can be written as e power j 2 pi fct plus e power minus j 2 pi fct divided by 2. That means in the lower class we already discussed that e power I theta is equal to cis theta. Cis theta means cos theta plus I sin theta. Similarly, e power minus I theta is equal to cos theta minus I sin theta. So when you add these two expressions, cos theta plus cos theta, 2 cos theta, that is equal to e power I theta plus e power minus I theta. From the above equation, cos theta is equal to, so e power I theta plus e power minus I theta divided by 2. So cos theta is equal to this expression. Similarly, cos 2 pi fct equal to e power ij 2 pi fct plus e power minus j 2 pi fct divided by 2 can be written like that. So this 2 is taken out. Okay, so the AC divided by 2. AC in denominator value 2 comes out. FC into. So we have to multiply mt into the bracket term and split into 2 different terms. So Fourier transform has been taken for the first term as well as for the second term also. So AC divided by 2 is a common, has been taken out. So Fourier transform of m of t into e power j 2 pi fct plus Fourier transform of multiply m of t into e power minus j 2 pi fct. Okay, remaining term. So when we are going to take a Fourier transform for this condition, so for this case alone, so the Fourier transform of this case, that is equal to capital M of f minus fc. So f means center frequency, fc means carrier frequency. So m of fc minus fc plus m of fc plus fc. So that means These are called as lower sideband, that one is called as upper sideband frequencies. So Fourier transform of lower sideband, Fourier transform of upper sideband within the bandwidth interval minus W plus or minus F and plus or minus plus W. So that means this expression is called as time domain expression for DSBSC. DSBSC or time domain expression. Similarly, we can calculate the frequency domain of DSBSC. Frequency domain for BSC, double sideband suppressed carrier. So this is the waveform of the message carrier signal. So carrier signal or frequency form, the amplitude of the frequency carrier wave, amplitude of the carrier wave is equal to AC, and the lower sideband, that means lower bandwidth, higher bandwidth value, lower bandwidth value. Next case, double sideband suppressed carrier order formula. Okay, so that frequency domain diagrams. Amplitude value is half of the amplitude of carrier wave. We should be draw the diagrams by seriously. மேலே ஒன்று வரைகிறீங்க, அதுக்கு நேராக கீழே வரையணும். ஸோ இந்த வெர்டிக்கல் லைன் ட்ரா பண்ணிங்கன்னா அந்த வெர்டிக்கல் லைன் ஸ்ட்ரெயிட்டாக அதுக்கு நேராக இங்கே இருக்கணும். ஸோ இங்கிட்ட மாறி வரைஞ்சிருக்கூடாது. ஸோ இந்த வெர்டிக்கல் லைன் ஷுட் பி ஸ்ட்ரெயிட் இன் போத் எக்ஸ்பிரஷன், இந்த போத் டயக்ராம்ஸ். இப்போ இதுக்கு நேராக அந்த வெர்டிக்கல் லைன் ட்ரா பண்ணுறீங்க. ஏசி இஸ் a maximum value for the carrier waves, but in the DSBSC waves this amplitude value is half. So that means AC by 2. Yes, the amplitude value is AC by 2. That's what the amplitude of the frequency values of DSBSC wave is half. So AC by 2 na idella பாதிக்கு தான் இருக்கும். ஓகேவா? ஸோ இந்த ரிசல்டன் டயக்ராமில் இதில் பாதியில் வரையணும். பாதியில் வரைஞ்சிங்கன்னா, so that means it's a center frequency, then lower sideband and upper sideband. In this lower sideband and upper sideband, frequency has been classified by two cases. So that means center frequency of the left side, center frequency of the right side maximum amplitude, and center frequency of the left side negative value of the maximum amplitude. So amplitude everythingla adla positive value and negative value. Appo positive value negative value nu solli renda pirikumbodhu, so upper side band la we can get a one type of the form, and the lower side band as well as lower side band and upper side band in the negative directions also we can get. So from this case we can find out the transmission bandwidth. So draw the diagram and explain in the positive side upper sideband and the lower sideband, as well as you have to write in the negative side upper sideband and the lower sideband. You need not explain the diagram deeply. Next, transmission bandwidth for positive side as well as for the negative side also can be calculated. That means FC plus the omega minus FC minus omega. So FC get cancelled, so omega plus omega 2 omega, so beta is equal to 2 omega. That means bandwidth, so the transmission bandwidth of DSBSC is same as that of the standard amplitude modulation DSBFC. So that means double sideband full carrier equal. So double sideband suppressed carrier bandwidth double sideband full carrier bandwidth values equal. So that means here from this case what they were going to say, carrier frequency, carrier power has suppressed. At the same time bandwidth, in bandwidth there is no change from the original standard amplitude modulated wave and the suppressed carrier double sideband waves. So the bandwidth la endha change illa, but its power value has been suppressed. So in the double sideband suppressed carriers power value has been suppressed. So what are the different methods for the generation of DSBSC signals? There are two different methods are available: switching modulator or ring modulator, balanced modulator. So these are the two different methods. You need not explain the methods of generation of double sideband suppressed carriers.